So, this is the second and last lecture of our uh, induction generator. Now, induction generator generally we means use induction generator in conjunction with our wind turbine. So, this wind turbine, we must understand what is wind turbine, and once we understand wind turbine, then only we can proceed with this. And for this, I would like to take rather I would like to take the privilege of extensively using data and information from two sources, chiefly one paper, that is even this image has been taken from that particular paper. The name of that paper is doubly fed induction generators systems for wind turbines by S. Muller and others like M. Dickey, Rick W. D. Donker. So S. Muller et al. I hope if you type the title clearly, you will get access to the paper. It is freely available in the website. Even in your Android device, you can download it and have a means uh, means it is very enjoyable piece of work. Anyone with any level of means who can read and understand English can understand at least 30 to 40% of what they have presented in the paper. Another one is from an MS thesis by person Jin Zing, who developed or who submitted MS thesis on that. So, the title of the MS thesis is Modeling and Control. Uh, this is another one, another resource that I am going to use for today's work. Modeling and control of doubly fed, because nowadays it is means everyone is looking for induction generator, renewable energy sources, and they are, if you are thinking about someone who wants to try their luck in the sector of renewable energy, solar is, you will face a heavy competition in solar. Rather, wind is quite free space and open, and like it's an um, open comparatively, means the amount of competition is somewhat means you will not face such a means tough competition like in solar. Solar, everyone is trying to contribute in solar, but wind is quite a free one, and you can do a lot of things with this feed induction generator for wind turbine generator systems. So it is very clear to you that both, this is by this is an MS thesis by Jin Zing. He it was submitted for and in the form of an MS thesis to so this is a bit means comprehensive. Obviously, it is a work of a serious student during entire masters means post-graduation study. So it is quite comprehensive and means contains many technical details. This one, but this resource anyone can understand. So this is turbine. This is actually known as a Danish turbine. The aim of these wind turbine systems nowadays is to continuously increase the output power. Because previously we used to, if you consider my last lecture, what I discussed that if we deploy small scale squirrel cage induction motor, then a typical output power, as the statistics shared by these authors, is roughly 200 kilowatt. For commonly available production unit, normal wind power range is 200 kilowatt. By 1999, the average power of new installations, as per their claim, has raised to the average power just changed to from 200 to 600 kilowatt, and the largest series production, this paper was written probably in 2004 or somewhere. At that time they are claiming that it is 1.5 megawatt output power is quite common, and in addition a prototype of Nordex N80. This is also a typical wind turbine setup system that may give power output as large as 2.5 megawatt. So 2.5 megawatt is not a matter of joke, especially if you are getting it without having much, like in case of thermal power plant you need to invest, but if in case of wind, if you do not need to invest much, then it is a blessing. Now you may argue for hydropower plant, but one like hydropower plant is also it is due to natural flow of water, and it is means water, a river flow of water is not, means obviously it is also a kind of, you can say, a renewable type of energy, hydropower plant, and hydropower plant are also very common in practice, but there is a little chance, or sometimes it is a high chance, depending on the nature of how aggressively you want to extract power from the natural sources, that you might have, means it is a debatable case that whether you will whenever you will try to erect a hydropower station, you must need to cause some artificial artificial dam and artificial some kind of water storage. You need to do some engineering with the river path through which the river is flowing. You need to do some engineering with that, and there is a risk factor that you might have ended up doing some geological imbalances, because I'm not a geologist, so I cannot comment much on that, and rather I should not do it. But it may cause catastrophic means like a flood or some kind of catastrophic natural, what to say, natural like it may totally devastate the surroundings locality if you just try to do much with that river flow. But in case of wind turbines, from that perspective, it is very, very safe. As per the research, as per my knowledge goes, although I know very little because this comes under power sector and my knowledge is totally limited to machine part. I am not expert of how to means this comes how you can extract natural sources and generate power. My task is being a machine engineer is primarily if you give me mechanical energy, how much and how efficient electrical energy I could produce, that is my headache, not how you can extract mechanical energy, whether you will burn tons of coals to produce that mechanical energy, or you do engineering with the river path, or you install wind turbine. That is the job of power engineer, not it doesn't come specifically to electrical machine people who are chiefly interested or means solely interested in electrical machine. They do not bother with that part. But if you are talking about a holistic approach, then this is very, very important for us. And that is why the wind means, and when you are trying to pursue a research, then also you need to take means synergistic and holistic approach, because you cannot say while pursuing a research that, especially in engineering field, if you are not doing any research in say in theoretical physics, that you are going to give something very novel proposition. Rather, you are trying to meet the demand of the market, and you being means if you want to do that kind of research uh, where you are trying to meet different constraints of markets and trying to just being an engineer, you are just trying to give an optimal trade-off between the different market constraints. You cannot say that I am a machine engineer, I will take means I don't care how you produce electrical energy, I need this much mechanical energy, you give me this much mechanical energy and I will give you this much electrical energy. That is my headache. But it would be more means quite a like, what can I say? It's a means practical approach, and like that will also make your research more interesting. If being an electrical engineer, being an electrical machine engineer, you say, okay, this much power is available to me, mechanical power, I accept your limitation, I accept your constraints, and with that, let me schedule some of my machines, some of my, let me do some kind of parallel operation, some kind of other means transformer, this, that, so I can finally meet the requirement. So we need knowledge in different area. And similarly, this double feed induction generator is very important. Now, while in double feed induction generator, if you think about it, what I would like to show you, because this doesn't come under the part of electrical machine, but without having knowledge of electrical turbine, we will not be able to means figure it out. So this is our normal wind turbine system. What is common here is that you can see that this is because we need to understand this technical term. This drivetrain system, basically, generally you will see that most of the cases wind turbine comes with 3 blades. So this drivetrain system comes with 3 blades. Now a low speed shaft, this is a low speed shaft to a 2 or 3 stage gearbox. You can consider gear is just analogous to your electrical transformer. Gear, sometimes we also call gear a mechanical transformer. Just like an electrical transformer just step up the voltage or step down the current. Similarly, gear step up, and what is electrical power? It is voltage into current. Similarly, in mechanical quantity, in terms of mechanical quantity, you will see, especially in rotating the mechanical devices that executing rotating motion, it's mechanical torque into mechanical speed that gives you mechanical power. So like electrical transformer that operates with the invariance, or means kind of means if you disregard the losses, it is like invariance of power between your primary and secondary. Similarly, in case of gear train, it is like the invariance of the torque and speed product. If torque is high, then speed is low, and if torque is low, then speed is high. It is their fundamental principle. Now, the low speed shaft connects with the low speed shaft to a 2 or 3 stage gearbox, right? This is our gearbox. Followed by a high speed shaft connected to a generator. So, this is our generator, right? Now, the process of how this wind turbine generate this is like the wind strikes the wind turbine blades, and therefore the blades rotate, and this low speed shaft that is directly connected to the blade, that also rotate. Now, the rotating low speed shaft transfers the kinetic energy to the gearbox, and this gearbox has a function to step up the rotational speed and rotating the high speed shaft. Here you can see that this head is having a larger radius, and that is connected to this high speed shaft. You can see the high speed shaft, it's the radius of gear is very small. So if this rotate at a speed of, let me give you one example. If their gear diameter ratio is like 5:1, then if one rotates at a speed of 20 revolution per second, the other will rotate at 100 revolution per second, right? Now, this gives us an interesting fact that this will speed up this one. Now, the rotating generator converts, like generator does in every cases, converts mechanical power to the electrical power. Usually the output voltage is quite low, the generator output voltage are quite low, and we need transformer and other things to means make that power means make this happen, make this power absorption happen from our generator output terminal. Now, there are few things that needs to be understood from the context of wind turbine system, based on our wind direction, we need yaw system. What this yaw system will do, they will rotate like this. Suppose the wind is flowing from north to south, and this one is such is oriented, this wind turbine, it is can experience maximum torque on the blade for an east-west wind. So what you need to do, you need to reorient this wind turbine so that it can experience that it you can reorient itself in experiencing maximum wind from this uh, north-south direction wind. And that is how this yaw motor, it rotates the whole assembly. Yaw means motion with respect to z direction. If we consider x, y, z axis, then say if this is our z, this is our so so yaw means motion with respect to z direction. Generally, this idea comes from plane or means generally in airplane we use this terminology. While we consider this airplane is made up of a cylindrical or means a cylinder shaped. Uh, so the axis of that airplane is aligned with x-axis, and if the airplane executes a nose up nose down motion, that is with respect to y, that is known as pitch. And if it just execute any turn in this xy plane, then that is the yaw angle, right? So this yaw motor actually reorient them. And in addition, what we have, an emergency brake. What that brake does, the function of that brake is to ensure that it just protect the drivetrain system from the mechanical stress in case of high speed wind gust, like in case of tsunami or means any such kind of hostile weather condition. This drivetrain must be disconnected, and at that moment you do not need to you will not consider about producing energy. Rather, at that moment it will be your objective to save your or means protect your system from that hostile condition. In addition, we have one like onboard controller that can change the pitch angle of the rotor blades. What is the pitch angle? Like how the rotor blades are placed. The rotor blades, it is how curved they are, or how much what to say, how much you bend a blade, or means how much you just uh, like we see during every time that if we change the it is the blade angle, you can say. If we change the blade angle or the pitch angle, then this blade experiences higher amount of torque, right? So these are all things that is very common. In addition, it contains several sensors like anemometer and other things to measure both speed and electricity. So, well, you get some idea about the wind turbine system. Now, see what is the problem associated with means conventional wind turbine system. Before I go to the means or explain this card, let me just quickly make you understand a few things that is associated with a normal wind turbine system. In case of wind turbine system, just a minute, I just need to take this picture. Yeah, this is the one standalone adjustable speed generator. The main issue of wind is that it is quite uncontrolled and the environment is quite dynamic. So you need an adjustable speed generator, and this key advantage of adjustable speed generator with comparison with fixed speed, we sometimes call them ASG, and fixed speed generator is FSG. So if we compare this ASG with FSG, first of all, these ASGs are cost effective and they provide simple pitch control. And the controlling speed of generator allow the pitch control time constants to become means you will get some extra time to do that pitch control and reducing the pitch control complexity. And you need pitch control to just consider the maximum or limit maximum output power at high wind speed. Like pitch control means even if you are not able to do or utilize, sorry, not utilize, rather install precious, like everything comes at means if you want some benefit you need to invest more, but if you are not able to invest much on the aspect of pitch control, cannot deploy a costly controller that takes precision means precise control of pitch angle calculation. You just only need to ensure that during high wind gust, uh, now everything is relative. You must do some analysis, it must have a threshold value, like above which your drivetrain will not work at all. You will have a brake and cut means cutout policy that will just disconnect and try to bypass everything from your system. While the other one is that where you have means it is within the safe speed limit, but the wind is flowing at a quite high means the means velocity of the wind is very high. Now in that case, you need in case of a fixed speed generator, you must be very cautious in pitch control. If you deploy a fixed speed generator, you need a very meticulous adjustment of your blade pitch so that you can reduce the speed, not reduce the speed, rather you can maintain the fixed speed. Because you can understand, if your wind velocity is very high, even having means small pitch or the blades are not so aligned, your blade will rotate at a very high speed. But when your wind speed itself is small, then you need like means good adjustment of pitch to ensure that particular fixed speed. However, in case of adjustable speed, it is a blessing in disguise that as you are not obliged to deliver a constant speed, means somewhat variation of speed doesn't make much difference in your case, right? Now, see what we can do here is that another advantage of this one is that it reduces mechanical stress and gusts of wind can be absorbed, and this additional energy, like you can understand, had we employed a synchronous generator in our wind turbine system, then during high speed, perhaps I have mentioned it during my last lecture also, during high wind gust, the delta will be very high and it may cause total damage of the system. But here, this will just work as an some like additional energy, and it will be absorbed in the wind turbine, means mechanical inertia of the turbine, and it will create an elasticity that reduces torque pulsation. Moreover, this adjustable speed generator, we can dynamically compensate the torque and power pulsation caused by the back pressure of the tower, and this back pressure causes noticeable torque pulsation at a rate equal to turbine speed times the number of the rotor wings. This is quite a technical term. What I'm trying to say that this like adjustable speed, we have this advantage. Another advantage is that this adjustable speed improve power quality and torque pulsation can be reduced due to that elasticity of the wind turbine system. Finally, this wind turbine system, like adjustable speed system efficiency, turbine speed, we can draw it as a curve, as you can see here, although this is not very clear. Just a minute. Now it is somewhat better than the previous one. Yeah. So this red, solid red line, it indicates electrical power. And this, all these curves, they are representing wind speed. So turbine speed, here you can see that for higher wind speed, again it causes this electrical power. You can see this is a torque speed curve as a function of turbine speed and wind speed, right? Now here this so basically what we are looking for, this is the maximum electricity we are looking for in all the cases, so that our this electrical curve passes through this maximum energy point. Try to understand this, what I am saying by this. It is also a common practice in solar. They call it MPPT, and probably many of you are going to do, following your the footprint of your seniors. Many of you are going to do thesis in that MPPT. What they do, they in solar also you will get this kind of point for different irradiance pattern, and that is the maximum power point, and same kind of things we are getting at wind turbine also. So goal is to get this point, right? Now here in this figure 3 we can see that this energy efficient improvement we can have, where we can have 10% energy efficiency is possible in our area, this area. So what we can do is that, well, so this one thing it's clear that adjustable wind speed or means sorry adjustable speed generation is quite helpful in the context of wind, right? Now we can have direct inline or ASG scheme. What is that? The direct inline or ASG scheme is this one. Here we are having the power converter which has to be rated at 1 per unit of total power system, and therefore this is somewhat expensive, right? This is a typical diagram. You are having this gearbox, and here you are having this ASG or squirrel cage induction generator, and this squirrel cage induction generator converts the power. Now another thing here is that you can see that this is basically trying to convert a three-phase AC to DC, and then again DC to AC. Now this inverter, I'm not sure how much you read all this in power electronics, and I have zero knowledge in power electronics, so I don't want to, or rather I cannot help you much in that area. But this inverter, this is a converter inverter setup. Here the inverter output filters and these EMI filters, both of them are rated for 1 per unit, and therefore they are very costly. And this converter efficiency plays a very important role as long as you are considering a single squirrel cage induction generator. This is rugged in structure, this is almost maintenance free, but this is somewhat not desirable in terms of the power output is difficult to control. Now here we would like to talk about doubly fed induction generator, this DFM. What is doubly fed induction generator adjustable speed system? This is an alternative ASD concept. This has a 4-quadrant AC to AC converter, and this will reduce your inverter cost. Okay, just a minute, let me tell you what is doubly fed induction generator. If you are not sure how this works, I suggest you to go and check the speed control of this wound rotor induction motor. In that wound rotor induction motor speed control, I have already discussed how in wound rotor we can feed sleep power to adjust the speed of an induction motor. Here in doubly fed induction machine, now after all this mechanical part, we will now go to the electrical part of doubly fed induction generator, that is right. So now we are going to discuss this particular topic. So here one thing that we must understand, that it is electrically it is almost similar to one rotor induction motor. So we should proceed in an according manner. So the mechanical power will be what? It will be that you can write the mechanical power input P wind is something like this. Is actually this rho air is air density. This is the total area of rotor blades. So this area actually means effective area is also a function of our means pitch angle. We can include and we can reduce this. Then we have our so this this CP is the performance coefficient of the turbine. Now in double-fed induction machine, what we do basically in standard wound rotor machine, with the stator windings is directly connected to grid, and the rotor winding connected to grid through a converter. Now this the AC DC converter divides this in two components: the rotor side converter and the stator side converter. For our ready reference, we can share. Sorry. So here we can see that this rotor, this is connected with an AC grid line. It is converter, and then this we should not forget that what comes from rotor, if we try to inject power, we must inject it at a frequency of SF, and if we try to extract power, that power will also having a frequency SF. Now this thing will go here. The basic idea of using this converter inverter, you can see it is converter means it converts AC to DC and therefore makes it steady one, and frequency related information is lost, and then converting it in corresponding value of is corresponding AC that is having frequency equal to grid frequency. So that is one way, and the other one is that the side that is already connected to your grid, and thereby it is improving that means how you can extract power from the stator. We must not forget that in case of standalone or even supported squirrel cage induction generator, when we were trying to extract power from the stator, there was no problem because stator is totally at grid frequency, so there is no need to introduce, means at least from frequency matching point there is no need to introduce additional circuitry, but of course that exists many other circuitry due to matching of voltage and other things, but otherwise for frequency matching it is not required. Now the obvious question that comes in your mind, then why do we need this at all? The answer is that sometimes this gives us a provision that if you ever means question yourself that what is the reason behind poor power factor or means induction generator, why do it need such a huge amount of reactive power during its start? The answer is that the air gap and you have to magnetize the core, but in some way if you trust somehow allow means flow of current through your winding during your start through this like this one, then your job is done, right? So that gives you an additional. Now in order to understand that, what we need is that I have taken one more slam. This is a particular speed control of our it is known as your means Kramer drive. The scheme of this Kramer drive is what? This is a speed control scheme. What it does, that it like this is a solid state converter, power electronics converter, you can understand. when you try to drive it in subsynchronous speed, if you want to means try to like reduce the speed, what you should do is here is very simple thing. You set the firing angle of all these thyristors in such a way that power flow from this rotor to here. What is the amount of power available to your rotor? That is SPG. In normal case, SPG is our rotor copper loss, but here this SPG can be suitably collected from our slip terminals and can be fed back to our supply. And another thing what you can do is that if you want to drive it in super synchronous speed, here this is super synchronous one, you just try to means push power, just change the angles of these thyristors and try to push the power here in the rotor at a frequency of F. Then what would happen, the rotor will get power and that power will push the rotor ahead of our synchronous speed. See, it is very easy to understand when what we know that when there is in case of squirrel cage induction machine, when the machine reaches the steady state, there is no requirement of power. That power becomes zero, generated power. Well, in that case, if your slip becomes, but it cannot, because obviously the torque will also become zero in that case. But what if we follow that notion, if the rotor power during no load condition, when the machine is running at, if we assume that somehow by some external means we are allowing the rotor to rotate at synchronous speed, even if it is a squirrel cage motor, then the amount of power absorbed by the rotor is zero, because slip is zero. Your machine is running at perfectly synchronous speed. Now, if you further inject power to your rotor, then what will happen? The rotor will try to move ahead of your rotating magnetic field, and thereby it will cause flow of means the rotor to rotate in super synchronous speed. Now, in case of wind turbine, it is quite the different. Here, you may feed sometimes power just to improve the power factor of your power quality of your machine. But once you are set, you will have a provisions, like if the wind speed is very high, then you have the provision, well, that even if it is high, it is within that set limit, then you have the provision to extract power in a twofold way. One is from rotor, another one is from stator. And when you start, in case of external rotor, when you start drawing power from the rotor, then what would happen? The machine will gradually, means it will create more counter torque on the machine shaft, and it will help you to reduce the amount of, means it will slow down the machine. And as soon as the machine will slow down, see the beauty, your slip, which is means in case of high wind speed, which is negative, means magnitude wise high, and high negative value is present for your slip. When you start absorbing power from the rotor start feeling powerless, and it will go in a deceleration, and that deceleration will do what? It will reduce the value of slip, right? So this is the very interesting case of our doubly fed induction generator. In doubly fed induction generator, what happens that sleep, that is even my wind speed varies, but I can somehow control the speed of the machine by extracting more power, which was a bit difficult in case of squirrel cage induction generator. In case of a squirrel cage induction generator, what is needed is that you need to, in case of squirrel cage induction generator, what is needed is that you need to like use a large converter or inverter unit that is of considerable price. But in case of this doubly fed induction generator, if you take care of rotor, then you have scope to adjust its electrical behavior. Now see what we can further write here is that about our electrical equivalent circuit. So what is that electrical equivalent circuit? Just a minute. So this is an equivalent circuit of our this DG. Here it is very clear that what it is happening, and if we try to write the power flow for steady state equation, I have already uploaded generalized theory lecture of induction machine. You can also find it interesting if you try to represent this by using that model DQ frame. However, the power in steady state, what we can write is that a very simple thing. The power at steady state will be how much? V1 I1 cos theta. What about the reactive power? Let it be sin theta 1. Then for rotor, what it would be? You need to memorize these few formulas. Actually, they are nothing new. You already know all these formulas. Angle between E1 and I2. Right. And if we want a DQ model, just let me insert that picture. So in terms of generalized equation, what we can write is very simple equation like flux linkage. We can write flux linkage. Where is that cursor gone? Is equal to LSS God. So LSSIS plus LMIR. Similarly, rotor flux linkage we can write like LRRIR plus LMIS, and you can write also US is equal to RSIS plus D psi S dt plus J omega 1 psi S, and UR is equal to R1, sorry, RRIR plus D psi R dt plus J, here it is omega 1 minus omega R psi R. Now from this, what we can write in Laplace, if we do take Laplace, what we will get from all these, US is equal to RS plus S plus J omega 1, here S is d dt, LSS minus Lm square S plus J omega minus omega R, omega 1 minus omega R, let me use different color so you can understand it clearly. R, LRR, I is. So this is the equivalent model of the generator, and accordingly we can write, well, one part I have missed, that is due to UR. S plus J omega 1 L M R R plus S plus J omega 1 minus omega R L R R LRR here into UR, right? So this gives the complete equation, and here it is the equivalent realization of the same. This side is US and this side is our UR. So that's all about the equivalent circuit of DFIG. We can do further analysis if you are interested. In exam, you can hardly expect only small logical question or something from, hardly at max 2 to 3 questions. But why it is important to know is that it is the future. So So we must not neglect this one.